Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We are just going to be doing some reviewing of factoring today. So we'll get right into it. And yeah, we're going to go through the different types of factoring methods. And then for the future next assignment, we will probably go ahead and just go ahead and figure out when to do what. So we're focusing on each different type of method today, but the important thing with factoring is to know when to do what. Okay, so we'll focus on that for the next assignment. So let's go ahead and get right into this. It says factor out the greatest common factor, the GCF. Well, if you recall, the greatest common factor is the largest number that goes into every number and the smallest exponent that each variable has. All right, so what's the largest number that goes into 7, 14, and 49? Well, the largest number that goes into all three of those numbers cannot be bigger than the smallest number, which is 7. And the only factors of 7 are 1 and 7. Divided by 1 is not going to do anything, but does 7 go into 7, 14, and 49? It does. We're going to plot a 7. And then what's the smallest exponent there? I see v to the 4th, v squared, and v. Which one's the smallest exponent? We have a v. We're going to plot 7v. And we're going to, now what we do, when we plot a GCF, we're going to divide every term by 7v, our GCF. So 7v to the 4th, 7s are going to cancel. V to the 4th, when you divide by exponents, you subtract them. 4 minus 1 is going to be 3, so we're going to get v to the 3rd. 4 minus 3 minus 1, or v to the first power is going to be v to the 3rd. 14 divided by 7 is 2. V squared divided by v is just going to be v to the first power, because 2 minus 1 is going to be v to the first power. And then we subtract 49 divided by 7 is 7, and then the v's are going to cancel, and we get our final answer. We get 7v times all of that. And there we go. All right, number 2, 16k to the 4th minus 18k to the 3rd minus 20k squared. Okay, what's the biggest number that goes into 16, 18, and 20? Well, the smallest number is 16, so what are the factors of 16? We have 1, 2, 4, 8, and 16. Well, let's start with the biggest number and work our way backwards. Does 16 go into 18? No. Does 8 go into 18? It also does not. What about 4? Does 4 go into 18? It also does not. And we have 2, so we can at least divide by 2. 2 is going to be our greatest common factor in terms of the number that we can pull out. So I like to start with the biggest factors and work my way down because we want the greatest common factor. So I divide by, so 16, it goes 16, 8, 4, 2, and 1. So none of these numbers went into 18, which I was checking, but 2 did. So we used 2 for this one, okay? Now, what's the smallest exponent that we have available? We have k to the 4th, k to the 3rd, and k squared. Well, k squared is the smallest one, so we're going to plot as k squared. Divide everything by 2k squared. Now we're going to get 8k squared. 16 divided by 2 is 8, and then 4 minus 2 is 2. And then 18 divided by 2 is 9, negative 9. K, 3 minus 2 is 1. And then we have 20, negative 20 divided by 2 is negative 10, and then the k squareds are going to cancel. Okay. Now, factor using difference of squares. So a difference of squares is literally what it is. It's a difference, subtraction, of two perfect squares, all right? A perfect square is something like 81 or 25, I guess we have it right there, or 36. Those are perfect squares because when you take the square root of all those, that's 9, that's 5, that's 6. They need to come out to perfect, nice whole numbers, nice integers or something, okay? So, what's the square root? We want to check if these are perfect squares. What's the square root of 25n squared? Well, that's going to be 5n, so that's good so far. What about square root of 16? Well, that is 4. That's good. So we have difference of two perfect squares. The way this is going to factor, it's not really anything I can really teach. It's just kind of a pattern. It's going to be, we're going to go like this. We're going to make our binomials multiplied here. It's going to be the first term's going to go here. The last term's going to go here. And we're going to put a plus and a minus between them. That's just what it is. If you were to FOIL this, the middle terms, this would be plus 20n, this would be minus 20n, and they would cancel out, and you'd be just left with 25n squared minus 16. It's just a pattern you just kind of have to know, okay? It's the square root of the first one plus the square root of the second one, square root of the first one minus the square root of the second one, and you're just going to put them side by side and multiply them, so. Okay? All right, next one, number 4, 9b squared minus 4. Are these perfect squares? What's the square root of 9b squared? Well, that's 3b. What's the square root of 4? That's 2, and it is a subtraction between them, which is good. So it's going to be 3b plus 2 times 3b minus 2. And that's it. That's all you got to do. There's nothing really to solve or do anything. It's just kind of a pattern you just kind of have to know. Okay? Now, factoring using grouping. We have 4x to the third plus 20x squared plus 3x plus 15. So we're going to put a slash between them. We're going to factor by grouping is when we factor out the GCF out of the first two terms and the last two terms. And then we go ahead and we do GCF stuff, okay? So these are both positive signs. We want to check the signs too. These are all positive, which is good. If these were both negative, we'd have to do something different here, but these are both positive, so that's good. So let's find the GCF. What goes into 4x to the third and 20x squared? We had 4x to the third plus 20x squared plus 3x plus 15 is the problem we're doing here. We can pull out a 4x squared. And we divide those both by 4x squared, we're going to get x plus 5, pulling out a GCF. Because the signs are the same, we're going to put a plus here. We're going to pull out a positive thing here. And what number goes into 3 and 15 nicely? Well, we can pull out a 3. When we divide everything by 3, we're going to get x plus 5. And now the GCF between these two terms is actually the x plus 5. We have two x plus 5s in common. So we're going to pull x plus 5 in front, and we're going to do 4x squared plus 3. All right. And that's all you got to do. If you were to FOIL that, you get back to the original problem. All right, now we have 5n to the third minus 7n squared minus 35n plus 49. Going to split these into two different parts here. Let's check the signs. This is a positive and a negative, and this is a negative and a positive. So these signs do not match here and here. So we're going to have to do something a little bit different to fix that. What can we pull out of 5n to the third minus 7n squared? Sorry, it's 5n to the third minus 7n squared minus 35n plus 49 is the problem we're doing here. We can pull out an n squared, and what's going to be left is 5n minus 7. And we're going to pull out, instead of doing a plus right here, when you have the signs do not match, you're going to actually pull out a negative right here. We're going to pull out a negative. What number goes into 35n and 49? Well, it's going to be 7. We can pull out a negative 7. And when you divide by negative 7, you're going to get 5n minus 7. And the reason we did that, if we pull out a plus here, we would have negative 5n plus 7, which would make these not match. If you're doing grouping correctly, these should both match exactly, okay? So that's kind of a workaround when you're solving this. If it's not, the signs don't match, you're going to pull out a negative here, and that's going to fix it for you. So we got to pull out the GCF, which is the 5n minus 7, n squared minus 7, and that's what's left over, and then there's our final answer. Okay, perfect square trinomials. So we have 16n squared minus 24n plus 9. The way this works, it's going to be a difference. It's going to be two perfect squares in the front term, the first term and the last term, and then the middle term is going to be double those two square roots multiplied together. Okay. So what's the square root of 16n squared? Well, that's going to be 4n. What's the square root of 9? That's going to be 3. So that's good so far. Those are both perfect squares. And the middle needs to be double 3 times 4n. What is that? Is that true? What's 3 times 4n? Well, that's 12n. And what's double 12n? That's 24n. So this does work. This is a perfect square trinomial. And the way it's going to factor, it's going to be just this. We're going to have something all square. We're going to do the first square root, the second square root. And it's either going to be plus or minus in the middle here. But because this is a subtraction symbol in the middle, we're going to pull out a negative right here. It's going to be 4n minus 3 all squared. That's all you got to do. It's just a pattern you have to recognize, like difference of squares. All right, number 8, v squared plus 4v plus 4. Is v squared a perfect square? Yep, square root is v. Square root of 4 is 2. What is double 2 times v? Is that 4v? It is. This is a perfect square trinomial, so all we have to do is we're going to do, this is all squared. We're going to do the first term, the square root of the first term, the square root of the last term, and this is a plus, so we're going to put a plus in the middle here. And that's your pattern. That's all you got to do. If you were to expand that out, this would be v plus 2 times v plus 2. If you were to FOIL that, you get back to this original problem right here, okay? But I prefer you to write it like this pattern right here. All right, smiley face method. We're going to go from easiest to hardest here. Easiest to hardest. All right, we have k squared minus 10k plus 16. So we're trying to unfoil. When we're doing factoring, we're trying to unfoil or undistribute. We're trying to get back to the original like foiled process here, okay? So the first thing we need is we need factors of the first term. So what multiplies to give us k squared? Well, that has to be k times k. That's the only thing that multiplies to k squared. Now we need factors of positive 16. That's going to give us a negative in the middle when we multiply these. It's called the smiley face method because we're going to check these terms and we're going to check these terms right here. It's kind of smiley face. So what multiplies to 16? Well, we have negative 1 times negative 16. We have negative 2 times negative 8. And we have negative 4 times negative 4. Those are what multiply to negatives, or positive 16 with a negative here. So what is going to be our answer? What ones are we going to use to add up to? Which of these numbers are going to add up to negative 10? Well, hopefully you said negative 2 and negative 8. And you can see negative 2 times k is negative 2k. And negative 8 times k is negative 8k. And that equals negative 10k. So this is the correct thing. If you were to refoil this, if you were to foil this out, you know, and distribute, you're going to get our final answer is going to be k minus 2 times k minus 8. And that's your final answer. Okay? All right, let's try number 10. We have b squared plus b minus 12. We are doing smiley face method. So we need to do factors of b squared, which is going to be b times b. That's an easy one. We need factors of negative 12. So that's going to be 1 times negative 12, 2 times negative 6, 3 times negative 4, or also the reverse of all these. These could be reversed, any of these. So we need something that's going to add up to 1b in the middle. It needs to add up to 1b in the middle. So what's going to add up to 1b in the middle? Well, hopefully you said, if like 3 and negative 4 is close, that's going to be negative 1b. But if I switch the signs, I do positive 4 and negative 3. That's going to give me 4b minus 3b, which equals 1b. So our final answer is going to be b plus 4 is b minus 3. And there we go. All right, getting a little bit trickier now. Now we have 2a squared plus 7a plus 5, and now we have the first term is not going to be just a squared. It's going to be 2a squared. So we need factors of 2a squared. Well, it multiplies to 2a squared. That's going to be 2a times a. 2a times a. Now we need factors of positive 5. Well, that's a good one. That's only going to be 1 times positive 5, right? So where should I put? We need the middle term when we add up the loops here, the smiles. We need them to add up to 7. If I put positive 5 here, do you see how we're going to get 10a already? That's already way over our budget. So we need to flip that around. We're actually not going to put 5 right there. We're going to put plus 5 right here and plus 1 right here. And that's going to work because we're going to get 5a and 2a, which equals 7a. And so it's just kind of guess and check. There should be a lot of eraser marks when you're doing these problems to kind of guess and check which combinations are going to work. So this is your final answer. Okay. Number 12, getting a little bit trickier now. So we have 7x squared plus 20x minus 32. So we need to multiply to 7x squared. That's a nice one. That's going to be 7x times x. So we don't need to change that very much. But we need factors of negative 32. This is going to be kind of tricky. We're going to have 1 times negative 32, or reverse. 2 times negative 16, 4 times negative 8. And is that everything? I think that's everything. Because 6, 5, 6, 7 don't go into that. So any of these or the reverse of these are going to work. So we need to plug in one of these combinations that is going to give us 20x when we're done with it. Okay. So let's try, let's see here. You could try any of these. 20 is not that huge of a number, so they're probably not going to be that big a number. So let's just try, positive 8 right here and negative 4 right here. Let's see what happens when we do that. This is going to be negative 4x, and this is going to be 56x. You see how that's way over 20? But what if we flip those around? Let's try flipping those around now. Let's try doing, let's see here. Negative 8 right here and positive 4 right here. That's going to be negative 8x, and this is going to be 28x. And that's going to work. That's going to be great. That's going to be 20x. So this is the combination we wanted. We have 7x minus 8 times x plus 4. And that is the combination that's going to give us 20x in the middle. All right, sounds good. Now, number 13 and 14 are a little bit trickier because we have factors that are going to multiply to 10n squared. We have a couple different combinations there. We have 10n times n or 2n times 5n. Let's just try 2n and 5n for now. We just got to kind of guess and check. And let's try, we need factors of positive 3. Well, that's nice too, because that's just going to be 1 times 3. That's the only factors of that. So where should I put things? I want to end up with 17n in the middle. Well, if I match the 3 with the 2, that's not going to help me out too much. What if I match the 3 with the 17? Let's put plus 3 right here and plus 1 right here. Let's see what happens when we do that. That's going to be 15n. That's going to be 2n. That is going to work. That's going to be 17n. So our final answer is going to be 2n plus 3 times 5n plus 1. And there we go. Okay, 14, tricky one. Here we go. We have 8k squared plus 19k minus 15. We need factors of 8k squared. So that's going to be 8k times k or 2k times 4k. And we need things that are going to multiply to that. And they need to multiply to negative 15. So that's going to be 1 times negative 15 or the reverse. 3 times negative 5 or the reverse. So let's try 4k and 2k just to try something out here. We need to add up to 19k. So where should I put things to add up to 19k? Well, let's try, why don't we try positive 5 with a 4k, and let's try a negative 3 with this. Let's see what happens when we get that. So what's negative 3 times 2k? Well, that's going to be negative 6k. And 4k times 5 is going to be 20k. So that equals 16k. So we're close, but that's not going to work, unfortunately. And if we use 1 and 15, that's going to be even bigger numbers. That's probably not going to work either. So let's try switching something up here. Let's try... I'm going to try 8k and 1k. And let's see if we can match some patterns here that's going to work. So what can we try? Let's try, we want to add to 19k. Let's try positive 3 right here and negative 5 right here. Let's see what happens when we get that. So negative 5 times k is negative 5k. 8k times 3 is 24k. Ooh, that's going to work. There we go. That's going to equal 19k when you add those together. So we're going to get, our final answer is going to be 8k minus 5 times k plus 3. And there's our answer, okay? So you literally have to try combinations of this and combinations of this that are going to add to the middle. That's all you have to do. It's not so neat and, precise. It's kind of takes some effort and it's guess and check. But that's kind of how it works. And... you just got to be patient, and there should be a lot of erasing when you're doing factoring because it just takes some time to guess and check. And the bit more practice you get, the better you'll be at guessing which goes where, okay? All right, thanks for watching. Have a great day. We will see you soon.